Welcome to this introduction video on how to issue W3C Verifiable Credentials via OID4VCI using the walt.id Issuer API and portal. First, we will take a look at how you can use the walt.id portal, a UI, for issuing and verifying credentials to issue a W3C credential. Then in the second step, we will take a look at the Issue API, which is running behind the walt.id portal, to see how you can configure different types of credential issuance requests and then issue credentials into an end-user wallet. Let's start off with the portal. Here, we provide a list of different verifiable credentials you can use to issue. You can check it out yourself by going to portal.demo.walt.id. For now, I will issue a bank ID credential. Here I can configure different types like the signature type for the W3C credential. In this instance, I will just use a short signature. Then we can also select the DID for the issuer. I will just leave it as default here as a SD-JWT. And I also can configure other things, which I just leave out for now. Then when I click issue, in the background, the Issuer API is called. And this OID4VCI offer URL is created and rendered as a QR code. We can also see it by copying this right here and paste it here and decode it. And so we can see here the credential offer that was created. It's coming from the issuer, demo, walt.id, and here we have also the credential offer URI. In this instance, we use what is called credential offer by reference, because it could also be included in this URL directly. But if we now go to this URL, we will see the credential that is offered, in our instance, the bank ID. Now, when we take this offer and go to the walt.id wallet, we can paste it right here and then receive our bank ID credential. This is a simple way on how you can start off issuing your first type of credential, just using UI components. But let's now take a look behind the scenes and how you can do it via our API. Here I'm at a hosted version of the walt.id Issue API of the community stack. You can find it under issuer.demo.walt.id/swagger. Here we get a bunch of different endpoints we can use for credential issuance. Now, for example, here at the top, these are all OIDC related endpoints. So these are required for the exchange between the issuer and the wallet. And most of them you will never need to touch because it's all happening behind the scenes. And you just focus on getting the right credential, the data for the credential, and then sending it off to your end users. walt.id takes care of all the standard related exchanges in the background. Still, it's interesting to look at those for time to time. Because, for example, if we take a look at the OpenID configuration endpoint, we will see a bunch of different information advertised of this issuer. And it's also this endpoint that the wallet calls during the credential exchange to get more information about the issuer and the credential that is offered. Now, here we can see that this particular issuer supports a bunch of different credentials. And that's also where it gets interesting, because when you set up an issuer, you need to make sure that your credential type, because you might have a custom credential type like my custom credential, needs to be in the supported configuration, because otherwise you can't issue the credential. And here we can see that the bank ID we just issued is also provided here in this credential configuration. You can learn more about how to do this configuration via the walt.id documentation. But let's now jump to the issuance of a credential. Now, here I have already prepared an example issuance request. First, the issue information. So the key of the issuer that is used to sign the credential we are about to issue. Then the credential data, which is the main content, so the credential that is issued to the end user. In our case, we are issuing an EID with a bunch of different credential subject attributes. We also provide an issuance date valid from an expiration date. Then below this, we find a so-called mapping object, which we can use to inject data at a later point in time. but we will talk about this a bit later on in more detail. Then I specify the authentication method of the user, because in OIDC, so in the exchange protocol for issuing a credential, there are two types of flows. The first flow being the pre-authorized flow, which we will be using here. In this flow, the user is already authenticated, and so we can just give him the offer of the credential and he can just receive it without needing to authenticate. Now, there's also the full authorization flow, where the user, the end user, the receiver of the credential needs to authenticate, for example, with an external IDP provider like Keycloak or Xero, and log in with their credentials there, authenticate, and only after they have authenticated, they will be able to receive the credential from the issuer. Now, here we will just use the pre-authorized flow. Then we have the selective disclosure object. Now, the credential we issued via the portal, the bank ID. If you look at here, we have all this different subject information, but none of this is selectively disclosable, meaning that the user, when sharing the credential with a verifier, always shares all the information that is in the credential. But with an SD-JWT credential, so as we configure it right here, so we're still issuing a W3C verifiable credential, but not with a JWT signature, but with a SD-JWT signature. And this enables the selective disclosure functionality, where we can now specify which fields should be selectively disclosable. And in this instance, we specify the date of birth to be selectively disclosable, meaning when the user then shares the credential with a verifier, he can decide to only share all the other fields, but not the date of birth. And so the verifier can't get access to this information. And then, as a last thing, we specify the version of the OID4VC protocol. Now, coming back to the top, we have our issuer key. Now, what's special about this here is that we provide the raw key in the issuance request, which is great in the sense that we can do the issuance right away without needing any external dependencies. But it's bad for production because you don't want to have this information directly embedded and passed in these requests. You want to have the key stored in a secure environment like an external KMS solution. And that's why next to providing this key as it is right here, you can also provide a reference to an external key that is stored in a KMS solution of one of our supported integrations. So we support the Azure Key Vault, AWS KMS, Oracle, and also HashiCorp Vault. So you could then just pass the reference to a specific key ID in a HashiCorp Vault instance, for example, and then the credential, when it needs to be signed, is sent to HashiCorp Vault. There it is signed in a secure environment. And so the keys never leave HashiCorp Vault. Now for this example, we will just use a regular key here and pass it as is. To help with the creation of the issuer key, together with the issuer DID, you can also use this onboard issuer endpoint. So for example, here I could create an ED25519 key and a related DID-JWT method. And so then I could use this information right below in my request. Now, the next thing we need to talk about is this credential configuration ID. And that's where we would come back to what we have seen earlier in the OpenID4VC well-known endpoint. Because if we look at here in this credential configuration supported object, we see these specific configuration IDs. And this is what we at the end then need to also provide in the issuance request. And so here we see our EID configuration ID, which we use right here. Then we have our credential data, so the context, the type, then also an ID, but this is will be replaced by our data function, which we provide here in the mapping object, which we will discuss right away. And then our credential subject information. Some issue information, where also here the ID will be replaced with a data function later on, and some date fields which will be also replaced by a data function. Let's talk a bit about this mapping object here. So here we provide always a key mapped to a data function. So, and if we quickly look at our documentation, we see here various different data functions that are supported. And the idea of data functions is that the content in your credential is always the most current and accurate. Because let's say I'm triggering now this issuance request, but this only creates the offer. It doesn't yet issue the credential, so it doesn't issue and sign the credential. And this offer can now be received immediately in the wallet, or it might also be received later in the wallet. And if it is received later in the wallet, there might be a change in the data that goes into the credential. And especially things like issuance date, expiration date, these things change and won't be the same value we would provide now. Also, for example, the credential subject ID, which is the DID of the holder, we don't know it yet because we only know it when the user scans the offer with his wallet, and then there's an exchange where the wallet sends the DID of the user to the issuer, and so the issuer can insert that. Which is why these data functions we can provide will be executed right before the credential signing happens. So the offer is created, this gets sent to the wallet scans the offer and then does the exchange, and then right before the issuer would send off the final credential to the wallet, the data functions are executed, and the result of the data function will be inserted in the credential will be signed, and then sent off to the wallet. Now here we use the UUID data function to create a unique identifier. We use the issuer DID data function to insert the issuer DID. The subject DID, we use a timestamps for the issuance date. Valid from, I actually don't have here yet, so let's quickly add that. And then the expiration date. A specifically interesting data function is our webhook data function. And in this example here, we see that we have a degree in the credential subject that we configure right here. Then we provide a webhook with a specific endpoint. And so when this data function is called, the endpoint is called, and whatever the result of the endpoint will be embedded for this specific field. So in this instance, example.com returns test data, which is why in the final credential, the name is not Bachelor of Science and Arts, but it's test data. We also have a webhook JSON, where you could, for example, replace this whole object right here, so all this content, with JSON data that is returned by example.com, which might look like this, and which would then result in a credential that holds this information for the degree value. And then here at the bottom, we provide the fields that should be selectively disclosable. So we provide the selective disclosure key, then fields, and then in fields we provide credential subject, which is the field we want to map into. And then we say, okay, this field itself should not be selectively disclosable, so this whole object, but we want to look at the children of this field, and specifically at the field date of birth, and this we want to make selectively disclosable. So this right here. And now let's go ahead and execute this offer. So we get our OpenID credential offer URL, which we already have seen in the portal example, and now paste it in my wallet. I will receive an EID credential. And when we now open this, we see not only the subject information we provided in our issuance request, we also see that we have the selective disclosure attribute, which is date of birth. And to now just show also how this looks like when we now would do a verification, we will see that when I'm now trying to do this verification, here I'm offered to select what I want to selectively disclose. And so I could now not share this information with the verifier. And with that, we reach the end of this walkthrough of how to issue W3C credentials using the walt.id issue API. You can check out a link in the description to go directly to our docs. Also, make sure to star our GitHub repository if you enjoy our tools. And with that, happy building and see you next time.